Welcome to Chibuzor Math Physics. In today's video, we shall be talking about kinetic energy. Physics generally is about our life. It gives meaning to the living things. It is about the physical quantities. It is all about what we can see. That's why I say that physics is life. In your basic understanding, you might have understood or talked about the laws of motion. That when an object is at rest, that object will continue to be at rest. And the object in motion will continue to be in motion unless acted upon by an applied force. But today, our main area and aim will be to concentrate on what is kinetic energy. The energy of an object because of its motion is what we call kinetic energy. We can say that the kinetic energy of an object is the energy that it possesses due to its motion. Or we can say it is that energy gained by an object from its state of rest to motion. If you drop a pencil or anything on the table, that object will continue to be in the state of rest until acted upon by an applied force. And that's the little illustrations I will use to explain what we meant by kinetic energy. So let's have that down, that the energy an object possesses because of its motion is what we call kinetic energy. It is interesting for us to understand and study kinetic energy. How is kinetic energy different from potential energy? Kinetic energy is due to an object's motion, whereas potential energy is due to an object position or state. We can talk about velocity. Velocity is an important factor while calculating an object's kinetic energy. However, we can say that velocity has nothing to do with an object's potential energy. You can check the previous video where I use practical example to illustrate the difference between kinetic energy and potential energy. We have formula of kinetic energy. So the following is the formula we use in calculation when we talk about kinetic energy. So we say that kinetic energy, which is represented by Ke, is equals to half mv squared. Ke simply means kinetic energy of the object. M is the mass of that object. Then we have V, which represents the velocity of the object. We can say that kinetic energy is an example of scalar quantity because we know we have both vector quantities and that of scalar. It is scalar quantity because it has only magnitude and no direction. So we can only talk about a kinetic energy in terms of its magnitude, that is without direction. The SI unit of kinetic energy is in joules, which is equal to 1 kilogram. So we can be talking about 1 kilogram per meter squared. And we know that an example of a kinetic energy would be if we talk about a semi-truck traveling down the road. That semi-truck that is traveling down the road has more kinetic energy than a car traveling at the same speed because the truck mass is much more than the car. We can talk about a river flowing at a certain speed. That river consists or comprises of kinetic energy as water has certain velocity and mass. We can talk about kinetic energy of an asteroid falling toward Earth in a very large number. The kinetic energy of an aeroplane is more during the flight due to large mass and speedy velocity. So those are the examples I can give in terms of kinetic energy. Let's now dive into the types of kinetic energy. If something is moving, it has kinetic energy. The faster the motion of an object, the more kinetic energy it has. So let's consider 5 types of kinetic energy. We have what we call the radiant energy. Radiant energy. We have the thermal energy. We have the sound energy. Electrical energy. And then mechanical energy. All these energies are types of kinetic energy. What is a radiant energy or radiant energy? Radiant energy is a type of kinetic energy as it is always in motion. So when an object is always in motion, we can refer to radiant energy. The more kinetic energy an object has, the more faster that object can move. And I said radiant energy is a type of kinetic energy as it is always in motion, traveling through medium or space. We can talk about an example of this radiant energy as ultraviolet light. If we take example, we can talk about the ultraviolet light. What is an ultraviolet light? An ultraviolet light is a type of electromagnetic radiation that makes black light posters glow, and this type of light is responsible for somatomes and burns. However, too much exposure of the UV radiation is damaging to living tissue. So when we talk about ultraviolet, we are simply referring to this kind of kinetic energy as an object continue to move in motion or traveling through a medium or space. We can as well talk about gamma rays. Gamma rays is an example of radiant kinetic energy. Gamma rays. Let's pick a different color. We have the gamma rays. What is gamma ray? A gamma ray, also known as a gamma radiation, because we are shortly talking about radiation. It is a penetrating form of electromagnetic radiation arising from the radioactive decay of atomic nuclei. And we can say that this consists of the shortest wavelength electromagnetic wave, typically that are shorter than those of the X-rays. And all this gives us practical example and usage of radiant kinetic energy. Like I said in the beginning, when we talk about physics generally, it is taking our attention back about our actions, what we do in our daily lives. So physics is about those physical quantities, what we can do and how they make sense in our daily living. What is thermal energy? Thermal energy is also known as heat energy. Why? Because it is generated due to quick motion of atoms when they collide with each other. So there is collision. We can talk about example of this as hot spring. Example of thermal energy, we can talk about heated swimming pool. Most of us are used to swimming, so when that is heated, we call this thermal energy, heated swimming pool. Another example would be hot spring. Etc. Many others. What about sound energy? Sound energy is produced by the vibration of an object. Sound energy travels through the medium but cannot travel in vacuum, as there are no particles to act as a medium. Example of sound energy is the tuning fork. We can as well talk about the beating drums. When you beat a drum, the sound travel far away. So sound energy travel through the medium, but it cannot travel in vacuum. And this is one of the examples we can talk about when we talk about sound energy. What about electrical energy? Electrical energy is obtained from the free electrons. This is obtained from the free electrons that are positive. So these electrons are positive and negatively charged. We can talk about lightning, batteries when in use. When you insert the battery and they are in use, there is this transfer of electric energy. And all these things that happen without our knowledge of it is an example of kinetic energy. Mechanical energy is simply the sum of kinetic energy and potential energy.